Hey everyone. Today we are going to be talking about how to make stylized metallic effects in Eevee. Metallics are one of those areas that is quite straightforward in Cycles, because Cycles just calculates realistic reflections and that makes them really easy if slow to render. But in Eevee things get more complicated because you can't easily get a realistic reflection to work with, so you have to jump through some hoops, especially for a stylized metal look. I needed to solve metallics for this CyberGirl character because she has quite a few of them. And a few months back I did find a decent solution using essentially a Matcap setup with a procedural texture. I tweeted about it, and that's actually been my biggest tweet of all time, so thank you to everybody who shared that. But there were some problems with the setup, mainly this high-speed flickering on the blade as you change the camera angle. So it needed a bit more work. But now I have solved those problems and I'm ready to tell you all about it. Let's start with a look at what this fake reflection is actually contributing to the material. Don't worry about all these nodes right now, I'm just going to show you turning it off. This is what the material looks like on its own. It still looks like a reflective material, but it also looks like it's just reflecting a grey room, because essentially it is. And since it's Eevee, it's difficult to make it reflect anything more than that. But when we mix in a texture that looks kind of like a fake reflection, and that also is going to shift based on the camera angle, then it gives the illusion that it's reflecting something else in the surroundings at a different angle. The specific texture I'm using could probably use a little bit more development, but the effect works. If we move down to the sword, which has a lot going on, and several versions in the material, we can see it even more. Take a look at the metallic gold, and now let's turn that off, and nowhere near as interesting. And that's with a lot of other textures going on, varying the color and the reflectivity and the roughness based on the curvature of the mesh. But when we bring that back, we really get that metal look. If we hop over to a Google search for chrome metal and take a look at some real chrome, we'll see that the chrome is actually defined by the environment it's reflecting. Without an environment, or without us having a clear idea of what the environment is, we're mostly just seeing white and black contrast. So in a stylized Toon material, we're not really trying to get a whole environment in there, but we are trying to replicate this contrasty look, and that is what we're going to do with our texture. We're going to start at the very beginning, understanding just what is going on with reflections and how they contribute to the look of a metallic shader. We've got a test file, we've got a monkey head with a gloss on it, and we have a point light. And it looks kind of shiny, but it doesn't really look metallic. And that's because it's just reflecting a black environment right now. I have a white world, but it's set on 0 strength. If I give it some strength, then, well, it's just gray all around, and it's adding light to the scene, even in Eevee, so everything just turns gray. So again, like, if you could put a metallic monkey in a perfectly gray room, it probably would look about like this. But even then, we would expect to get some reflections. Now let's look at this same monkey in Cycles. This is already starting to look a little bit more metallic because we have some bounce light that bounces off one part of the model and hits another. In a moment, we're going to add more objects to the scene and build up even more bounces to get even more of a metallic effect. But before we pursue that path, there's another issue. If we go into Material Preview in either Cycles or Eevee, suddenly it looks more metallic. It doesn't make a difference which it is, because both is a Eevee render with a built-in HDRI texture on the world. If we unhide our sphere here and turn down the roughness on our gloss, we can see that it's reflecting a complex image, some sort of nature scene. This is definitely looking like they're made out of chrome now, but there's some reasons why we can't use this method. First of all, we don't want to be stuck in Material Preview mode, we want to use a real render, but that part is easy to solve. We can just go into the world, and I have my own real HDRI image to plug in. And it's this nice lake scene. So the reason, though, that this can't solve all our problems is that it's reflecting too complex of an image, And we can't make this world apply only to our metallic objects. It's going to apply to everything. And that means it's going to mess up all of your Toon shaders in Eevee, because Eevee Toon shaders are made by taking a shader and converting it to RGB and then color ramping it, and that doesn't work when you have a ton of extra light info coming from the world. And there's no way to say that the world will affect only some materials and not others. So using a fancy world to create reflections does not work as a way to get metallics. So world textures are no-go. Let's get rid of that. And let's get ourselves some gloss roughness back so we can see a bit more. And let's take a look at what our options are in cycles for reflecting the environment. Now let's give it something to reflect. I've made a big array of square emitter planes. When we render that, we can see them reflecting in the objects. And if we turn down the roughness, it really starts to look like a chrome reflection. In fact, we're used to seeing squares in reflections because that's commonly done in photo studios with square lights to get catch lights in the eye, and you'll often see drawn styles duplicate that. And we can make it even more interesting by enabling this floor plane. This is a diffuse, a regular diffuse, and we can see that it's bouncing a lot of light. It's both bouncing light and the gloss is reflecting the light. With more roughness, we'll see the effect of the reflection diminish. And of course, it smooths out all of the shapes. We stop seeing the boxes at all. And we can make our reflections even crazier. On the floor material, let's plug in one of those crazy colorful magic textures. And now we can see that on the floor, and we definitely see it reflected. If we use just the black and white output, this is really adding to the chrome effect. And we can even take it a step further and use isCameraRay from LightPath to make it so we don't even have to see the floor. Using this method in cycles, you can definitely set up defining your metallic reflections. You can get stylized reflections by defining what objects reflect. But again, just like with the world, you have the problem that you can't tell other objects not to reflect this. Still, if you have a fairly realistic scene, it should be viable to have your reflections be based on really reflecting the scene, especially if you want realistic reflections instead of stylized ones. So why don't we go ahead and switch over to Eevee, and it's all gone. The annoying floor is still there, but our reflections are gone, because Eevee doesn't calculate reflections like Cycles does. Now what it does have is screen space reflections, so we're going to turn those on, and we can still see our floor, but our rack of square emitters is not there. Also, if we zoom in, things are actually pretty noisy in the Eevee screen space reflections. You can see aliasing here. Now, what screen space means is only things that are visible to the camera are counted for the reflections. So if we take our floor plane and move it down, then as it leaves our view, the objects don't reflect it anymore. Whereas in Cycles, if we move it down, even after it's left our view and gotten pretty far away, they continue to reflect it because it's really calculating those light bounces. So Eevee sort of can do reflections, but you're limited. If you are dedicated enough, Eevee does have indirect lighting tools here in this tab, where you can bake out light maps and get around some of these screen space issues. But there are still some aliasing and quality problems, and ultimately you do have the same problems as Cycles, where your reflections will often be too realistic for non-photorealistic work. And overall, it's just a hassle of a workflow for things that are going to be animated and moving, although it works very well for static scenes like environments. So, if Cycles' real reflections don't really work because it's Cycles, and Eevee's sort of work, but it's a bunch of work, then what options do we have left? And this is where we get into matcaps and reflection maps. Both a matcap and a reflection map are methods of using an existing texture and, well, putting it on the model. Let's get rid of this floor plane and bring in some other shapes for our experiment. I'm going to turn off screen space reflections. Even got our sword and a long cylinder. so we can get a good look at how each of these affects these props. Reflection mapping can refer to lots of things in different programs, but generally in Blender it refers to using the reflection output of the texture coordinate. Let's try that on an image texture. We're going to use our Ice Lake HDRI and put it as the gloss color. And now let's give ourselves a bit of world color so we actually have some illumination, and we're getting a pretty good chrome look. If we turn this down, well, regardless of our roughness, we can see that the ice lake is acting like it's being reflected. It's not a physically accurate reflection, it's not quite the same as if you put the ice lake on the world. But what this does let us do is selectively put a reflection texture on only one object. Earlier I said that you can't restrict the world to only be affecting certain things, but you can do this. But of course, this isn't really a true reflection, and like if we adjust the roughness, then it's not, blurring the reflection. This is a color. Because it's a texture, we can have quite a lot of control over it, though. It's a color, so we can work with it with all our usual nodes. For example, to make it look more like a chrome effect, we might convert it to black and white, and maybe put it through a brightness and contrast, bump up the contrast a bit, give it a bit more light to reveal more of it, and that's looking like a pretty good reflective chrome there. But of course it's not influenced by the roughness, but that's just a sacrifice we have to make. This isn't the only way to use it, of course. We don't have to plug it straight into our gloss. For example, if we wanted a little bit more control, let's have our gloss be white and then mix this with the gloss. And there's lots of mix factors you can use. I like to use linear light, which is going to give us a bit of an overlay, and that gives us more of a chrome effect, even if we turn off all the world color. And now, as we adjust the roughness, it's kind of, revealing more or less to the texture. Ideally, we would have an option to just blur the texture to simulate roughness in the reflection, but since it's an image, you'd have to do that externally. Or you'd have to mix noise into the reflection coordinate, but then that sort of works as a blur effect, but it gets messy. Our nodes are going to get more complicated now, so I've redone the view. Let's take a look at what happens if we use reflection coordinates with a procedural texture, as that way we can build up our own fake reflections. I'm going to grab us a magic texture, as it is beautifully annoying, but also really easy to see what's going on. So with object mapping, that's what it looks like regularly. Now with reflection, we can see that as we move, it changes. And we especially notice this on these long, flat faces, like the sword blade and the cylinders. Let's turn the frequency down a bit. If we look at the monkey, we can see that in the areas that are broader, it's lower frequency, and in the areas that are tighter, it's higher frequency. Whereas on the sphere, it's always the same amount, and it's the same amount here. The reason for this is that the frequency is actually based on the curvature of the face normals. So totally flat areas, there's very little frequency, and the more curved it is, the more busy it is. And for this reason, reflection coordinates aren't actually the greatest for faking these reflections. Let's see what this looks like if we plug this in here. Don't do the black and white anymore. What we can see now is that in some areas, it's working pretty well. Let's get a bit more contrast. There we go. Like on the sword blade, that actually looks pretty chromy. But then on the more curved areas, like the monkey head and the sphere, it looks too much like the real magic texture, and it just doesn't really work. And if we look in detail at the sword handle, it's pretty good on the top parts where it's smooth and it's stretching the texture, but on the more curved areas where it's not stretching, it's not that great. And we can also see, as we move the camera, on the sword blade, we get pretty bad flickering, because what's happening is it's changing the, as our camera view vector changes, it's changing the reflection vector. And since we have a high contrast texture, it's like strobing and flashing between a black and a white part of the texture pretty fast. So that's not really accurate. It's proper for the reflection to change and move a little bit while you're rotating the view, but this is too much. So even if we are happy with how this looked in any individual view, it's not really going to work overall. It's the same problem I showed at the very beginning. If we want to see that problem really badly, let's turn on a totally flat-sided cube. It strobes really badly because there's just no curvature to work with. The flickering problem isn't only a matter of moving the camera. If we rotate the object, we can see we get really bad flickering. Now imagine if you had an animation where an object was moving and the camera was moving at the same time. It would just go totally crazy. So overall, using the window reflection coordinates and a texture can work quite well for stills. You kind of have to choose maybe different amounts of scale for different areas of your object. Like, I'm pretty happy with the way this looks on the guard here. And on the blade, it looks good at any still position. But I'm not happy with this texture on the handle or on rounded objects. But you could change the scale with another texture input or a mask, or you could use different ones on different materials and work around that. So that's reflections and their limitations. Now we can move to our next option, Matcaps. You're probably familiar with them from the viewport. If we go into the viewport options, we can go to Matcap and hey, there's a reflection. There's basically a chrome material. It doesn't really have enough contrast, but it is giving us a shiny look. It's not going too crazy on the broader parts, and it's not flickering that badly on the flat blade. And it is a little bit, but it's not that bad. The only problem with it is it doesn't really have as much contrast as we'd like, but there are other options. This one's got a slightly different pattern. And that one's just black. But, you know, if we had a matte cap like this with a bit more contrast, then that would be most of the way there. Combine that with the regular gloss shader, and that's pretty much it for your fake reflections. So can we get that in our material? Well, yes. Here's a sample matte cap I made for this project. I'll show you how to make it in a moment, but first I will show you how to use it. We've got to turn off the other one. Start rendering, and I've got it hiding up here. Take a look at that. We can see our matte cap. Let's look at what the matte cap is actually doing on our objects. I used one this simple with two simple elements so we could really see what was going on. On the sphere, we just see the matte cap, and it doesn't change no matter what the direction, because it's sphere mapped, and sphere mapping to a sphere just gives you the flat image from any direction. On the other objects, though, it's still there, but it's distorted. We can see on some of the rounder parts of Suzanne's eyes the recognizable shapes in the matte cap, but in the other areas, it is stretched. And in some areas, that stretching is really quite extreme, like the long cylinder and the sword blade. Now, if we take a look at this cylinder and we unsplit the normals, suddenly we see it, because right now it's just got smooth normals and it's trying to shade this like it was a sphere. So you can see a bit of what's going on there. But as soon as we turn auto smooth back on and get those hard edges, then these flat normal areas basically become a stretched version of the texture. The way to think of what a matte cap is imagine you have a sphere with your texture on it, with your matte cap on it, and then you morphed it into this other shape, stretching the texture. That's basically what's going on. Of course, the reality is there's a bunch of crazy math with normals and stuff, and mapping to the normals. And the reason that the matte cap display on this object, for example, changes when we move the camera is matte caps are a function of both view angles and object normals. So let's plug this in like we were using the previous texture. We'll put it into the linear light and into the gloss. And our pattern is a bit too simple for this really to look chromy, but you kind of get the idea. But so far, this is basically behaving the same way as our reflection maps were. So what's the point? Well, The Matcap has more options, and that's because of the vector changes that need to be done to make it work in the first place. This is the node setup for the Matcaps to have proper mapping. We take the normals, we convert them from object to camera space, and then we adjust where the center is and the scale. Otherwise, the texture is going to be stretched or in the wrong place. We turn these back to 1, we can see it's now repeating. And of course, if we move the location, it's going to be offset. If you've watched my previous videos on the procedural eyes, you'll recognize some of these transforms from other things we've done to make image textures centered properly. So, how do we make this different from the reflection map? We can use this little trick. Instead of object to camera, what if it's object to world? Immediately the matcap is distorted, but now, as I move the camera, it doesn't change. Of course, this isn't really going to look right for this matcap. We could try, adjusting the mapping to line the texture up or something like that. But what this is really useful for is if we wanted to use it with a procedural texture. Let's grab these nodes and bring them down to our magic texture and hook that back up. And now it stays still. If we set this to camera, it moves much like the reflection texture, although it's different in that if you look here, we're always seeing the same texture no matter the angle, whereas on the reflection texture, that was not the case. So this is a similar effect, but different. Also notice that it's not as busy, it's not as affected by the curvature, because while it is being distorted by the curvature, it's different math from the reflection texture. So matcaps have given us a similar but subtly different set of options. Of course, there's still problems. It's not changing when we move the camera, but it's still changing when we rotate the object, and that brings back our flickering problem. Now, of course, since that flickering problem only exists on long, stretched areas, it's not a problem on, say, the crossguard, the hilt here. And I think that looks pretty good, actually. And it's actually behaving quite well on this part of the handle as well, and that's not just because of the scale differences. It's because it's less affected by the curvature, as I said. So I think I'm pretty happy with this matcap moving based on the camera for the handle and like the pommel here. And if I was doing it on Suzanne, I'm pretty happy with this. Now, I'm not entirely happy with the magic texture on Suzanne, but we can use any procedural texture. We're just using magic for the stretchy areas, actually. All right, so far we have looked at doing real reflections in both Eevees and cycles. We have looked at doing reflection coordinates, both with images and procedural textures, and matcaps, both with images and procedural textures. And each of those have had different strengths and weaknesses and different pros and cons, but none of them have addressed the flickering problem on long, stretched, flat areas. So now we're going to look at our final method, which will address that. We need a solution that will avoid flickering both from camera movement and from object movement. So rather than try to remove flickering from our existing method, what if we started with a method with no flickering and then added some, but less, so it wasn't too much? For this, we are going to look at more typical texture coordinate options. If we use, say, a generated texture, then of course everything is static. Or if we use an object, it's also static, or UVs. If we use camera or something, that's just camera mapping it, that can work, but that will have flickering. And now our texture actually isn't stretched, because what's making it stretched is the use of normals. And if we take a look at our normal pass, what we'll see is on long flat areas, it's basically the same color. So whereas on curved areas, then we have more of a gradation. So that's why we're just seeing the same texture basically stretched, is because it's long and flat. That's why I have the example objects that I do. So we can use something like generated or object coordinates, and then everything works properly. But how do we stretch it on the blade now? We can get a mapping node. And now if we adjust these, it's going to stretch it in various orientations. Let's see, that's perpendicular to the blade. I guess we need Z. And this is responding to the object's rotation. So it's Z because that's actually the object's original orientation. So we're not even sure what orientation for different objects. So what's stretching it along the blade horizontally is doing different things on these. And that's not really going to give us like stretched lines down the blade like we have from normal. You know, here we kind of have parallel lines. So it's just not enough control, especially for a curved blade. On a straight sword, it would probably work. But we're going to need to be able to work with this curved blade, and that means we need to use UVs. With UVs, it looks like this, which doesn't really look any different at first, but now we have the difference that if I take this and I start scaling things, now we're getting a nice stretch down the blade. And maybe I'll adjust the X a bit to control how much of it. And it's even tapering to a tip on the blade. And the reason for that is the UV map of this sword. Let's take a look at just the blade's UVs. I've got them over here. And they are laid out into a nice, big, beautiful square. And this took some time working by hand. I used UV squares and snap to axis, which lets you select some points and snap them into a thin line, or a straight line. So whatever object you're working on, you'll need to be able to get clean UVs like this if you're going to use this method. But because of that, we have full control of the blade's texture. So let's turn off everything else because they're not really relevant anymore, and refine just the sword a bit. I'm not sure I want exactly that much. I'm going to leave X at 1, and instead I'm going to mess with the scale of this texture. And we can mess with the depth. And that's working pretty well. How about that? Brightness, a bit more contrast. That's looking kind of like a reflection texture, but of course it's not moving. So the next step is to add some movement. Moving the texture is simple. We can adjust its location in any direction. And hey, that looks like the flickering we've been trying to avoid. So basically, if the location changes too fast, it's going to look like bad flickering, and if it changes slowly, it's probably going to look about right and give us the proper impression. So what we need is an input that gives us some change based on the camera, and there's lots we can use. I'll show you a few of them. Let's start with the simplest, which is a layer weight. If you're not familiar, layer weight gives us a facing. It's changing the color essentially based on our facing to the normal. So black is facing straight on and white is facing at the edges. And we can adjust the blend for how much. We'll leave it at 0.5. And what happens if we just plug this into our location? And hey, it's changing as we move. And it's changing too fast. It's the flickering. So that's a bit too much, but that's the right effect. So let's turn this down a bit. Get a converter, math, multiply, and set it down to, say, 0.1. And now we're getting some change, but it's not very quick. This might actually be too slow. Let's try that. There we go. The texture is moving in response to our camera moving, which gives the impression of a reflection in the scene, changing based on the angle of the blade. And it's the same whether we're moving our camera or the object. So that's the right idea, but let's get even more control of it. Let's make 2 of these and get a vector combine XYZ so that we can affect different channels separately. Since it's UV and we're working with just X and Y, we can set a different speed for the horizontal and vertical of the UV. In this case, this is X and down the blade is Y. So let's try doing something like 0.1 per X, and let's turn Y up to like 10 so we can really see it. And when we go in this direction, It moves about that fast. And this direction, it goes crazy. Now let's switch those, just so we really observe the effect. And up and down, now the flickering is crazy, and side to side, there's still a fair amount because I'm not getting a perfect side-to-side movement, but it's not as bad. So realistically, we might want, say, like 0.5 and 0.2. This is where you can start making artistic decisions of how you want it to look. So that's one option for altering our location, which is convenient because we can change it easily, and you can adjust the blend amount to also change it. Now let's look at another option. We can plug reflection into location. And now it's going kind of crazy again, but it is moving. It's kind of hard to see. Let's see if we adjust this down a bit. That's a bit easier to see what's going on. We turn down the light strength and turn down the contrast a bit. That's okay. And of course, if we want, we can take some vector math and do the same thing to alter how much of it is applied. So 1 is what we were just looking at, but we can do a 0.1 and put a 10 there and a 5 and get all sorts of different speeds on the different axes. So that's another option. And there's also more things, like in geometry, we have stuff like incoming. So we can stick that in. And again, we can control it with the multiply. And that's also giving us some different effects. So all of these are going to give you like slightly different character. I haven't really experimented with them in super detail, but you get the idea. I'll go back to the layer weight, because that's what I actually used for the CyberGirl sword. I'm pretty happy with that. Maybe get some of that contrast back, and a bit of... I think I turned the light down too much. Let's bump that back up. But of course, this is working pretty well on the blade, but it's not really working on the crossguard as well. Oh, it's not terrible. But what we'll probably want to do is create separate materials for the blade and the crossguard, which is what I did in the CyberGirl file. So let's bounce back over to that and see how I actually finished up the materials. Alright, so we're back at the CyberGirl where we started with the upgrades that we've learned about. So for the gold on the crossguard, that's using just the Matcap method we learned about. It looks a bit different here. I don't have a normal input coming in because I've actually got a group that has a bunch of like pre-baked textures, including normal maps, but it's the same basic idea. It's going object to camera because I'm happy to let some movement happen there. And for the other metallic silver that's going on the headset and other curved items, that's staying just how it was. I might adjust the frequency of the texture on this one, actually. Let's try that a bit higher. That might be too busy now. So, you know, these aren't the final settings, but you get the idea. And then I've broken the sword blade off into its own material, and to deal with its horizontal flickering, we're using the layer weight method. And again, this is getting the normal maps affecting the layer weight, which is nice, because some of those are providing more curvature, actually. And we've got 0.5, 0.2, split between X and Y, magic texture, different scale and contrast than before. In fact, it might have too much contrast now. I'll still have to think about it. But again, the point is, it is working. Alright, that is the end. You should now have a good idea of what your options are for faking different types of metallic effects, or for doing the real thing if you want to. I haven't gotten into talking about the shaders themselves. Of course, you are going to want to use a proper metallic shader with this, and by that I mean one that mixes diffuse and gloss using index of refraction, or using the principled BSDF with the metallic slider, which is doing the same thing behind the scenes. If you're not familiar with making metal shaders, then that's just a regular Blender thing you can Google. But learn about Fresnel and combine that with this to get this full effect. This shader group I'm using here is the same one from my earliest video on making a Toon shader, so if you want to know about that, go ahead and look it up. I will be throwing the demo file that I was working in up on Gumroad for free. There's not much in there, but if you want to look at the same things I was showing, you'll be able to download it in the description. If anybody has any questions, feel free to leave a comment, or if you make something using this technique, I can be contacted on most social media platforms on the About page, and I'd be happy to reshare you. And of course, I'd like to say a big thank you to my supporters on Patreon and to the people who buy my files on Gumroad. If you find this content interesting, please consider signing up. And of course, don't forget to like and subscribe. Thanks, and I'll see you next video.